So welcome everybody. Again, my name is Ben Gromicko. I am from InterNACHI. We're the world's largest organization of residential and commercial property inspectors. We essentially train inspectors all over the world. And we have over 30 certifications from which to choose. One of them is home inspector certification. And another one is, but there's over 30, infrared certified. So we're going to learn a little bit about what that means. What does it mean to become infrared certified? And if you need to contact me or anyone on the staff at InterNACHI, go to nachi.org/contact. And again, if you want to take a look at the past classes that we've had, live, free, online classes, that's nachi.org/webinar. Today we have John McKenna. John has been a home inspector for 15 years at least. He is a certified master inspector. He is a Texas certified instructor, and he is a licensed home inspector. And we have been working together. He's one of our main trainers at InterNACHI, and he's one of the very first to develop an infrared class, a certification based upon building science principles. And building science is understanding how a house performs, functions, breathes. And every home inspector should get a chance to take a class, especially a live class that John presents and offers, and learn more about building science and how a house is a system of interdependent parts. When you affect one part, all other parts are affected. So, John, are you with us?
Yes, sir. I'm here, Ben.
So, John, explain where you are, and I want to tell everybody that there is going to be about a 5-second delay because of where you are.
Right now, I'm in the Dominican Republic, so there, like you said, there may be a little delay in the sound of my voice.
Yep, and so a little bit of logistics. We can't see you, the folks who are registered and attending the live class. We can't hear you. Your microphones are turned off. John isn't on with us live video, but he is with us audio. So you should be able to hear us and see us. And John, I have a screen here, just so everyone knows, before you start your first slide. And I wanted to show everybody what I got as a nice toy. We're going to do a training video. It's the FLIR camera, infrared camera. It's relatively new. It's a C2 camera, and it takes pictures, not video. There's a big picture button, and good battery life. It's not a thing that you connect to your iPhone. I have one for the iPhone 4 that snaps on the back of an iPhone. It's an infrared camera for a few $100. This is a few $100. This is a low resolution infrared camera, probably really good for beginners. And it just fits in your pocket. So here's my hand on the table, and it leaves that temperature mark. And John will talk a little bit more about that. So I just wanted to share with you what's out there. There are affordable, low-resolution cameras out there, and it's a good way to get your foot in the door, so to speak, and to experiment. But the number one thing you don't want to do is take an infrared camera on a home inspection without proper training. So that's why we are concentrated on getting technically proficient at what you do during a home inspection and really good at the specialized equipment that you may be using, including a moisture meter. So I like to pair up an infrared scan with a moisture meter because I want to confirm what I visually see with the moisture meter. If it's moisture, then I want to confirm with that. So John, You want to go to your first slide and start the presentation?
Yeah, that would be good, Ben. Yeah, that would be good.
Take it away.
We get a lot of questions that people come to me all the time with the question. People come to me all the time with a question about certification. And briefly, the history of certification goes back to the terminologies I'm sure all of you have heard: level 1, level 2, and level 3 certification. And those were the titles of classes that were created over 25 years ago. And when those classes were created, the introduction course to thermal imaging was called level 1. And they didn't use the infrared camera back then in the same way that we do now. There was not a concentrated market for building inspections. So even the manufacturers of the cameras were not creating cameras at the time and concentrating on the building industry with thermal imaging. So if you go and you take a level 1 class today, many times they're using the same outline that they did 25 years ago. And as a result, they give a wide variety of different applications of how the infrared camera can be used in different industries. But what we did at InterNACHI is we wanted to take the same content, the basic principles of a level 1 class that were necessary teachings, and cut out all the fat. And so we inserted into that content the knowledge of buildings, 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 and buildings. That's all we talk about during our 2-day class, is how to apply the thermal imaging knowledge to the diagnosing of a building with your infrared camera. So there is no certification requirement anywhere in North America to become legal or to be licensed to use a thermal imaging camera. But certification simply means that a school has certified you that you have reached a certain level of education or knowledge. The general home inspector customer out there, in the many years that I was doing thermal imaging during my home inspections, I never had one single person ever ask me, where did you get your certification at? These are things that they don't know about, they don't understand, they don't even ask about. But they do want to know that you have training and that you have been certified. So with that in mind, let's go to our first slide there, where you see 2 cups on the set of steps right there. And what I want to draw your attention to is the fact that in the thermal imaging picture on the right, the set of steps has disappeared. It's completely gone. And the reason for that is because this is called a poor delta T environment. The word delta T means temperature difference. And the steps have reached a place where there's no temperature difference from one step to the next step. They're all one single temperature. So I call a poor delta T environment the 900-pound gorilla. It actually can make your camera blind where you will not see things, okay? And by this illustration, you can see that if an entire set of steps can disappear and not even be there on your camera's viewer screen, how much more could a little moisture spot in the wall that's behind the sheetrock, how much more could that disappear if you're in a low delta T environment, or you're in an environment where the temperature difference between the subsurface moisture and the surface of the wall is almost the same temperature. See, when things reach that place where there's not enough difference in temperature, your camera does not see any difference. Therefore, it's just a flat, foggy image, and things begin to disappear. So with that in mind, we go over in the class the strategies and different methods and techniques of how to draw subsurface temperatures to the surface. Now, if you develop these techniques and you know how to do this, you can increase the potential of what your camera can see by well over 1,000%. But without this knowledge and these methods and techniques to draw subsurface temperatures to the surface, you can be blind to many defects and you won't even know it. You can go through the house and you're just looking at everything and you can't see some of the defects because that temperature is not coming to the surface, okay? And there is a method that must be done, and in different environments and in different ways, you can draw these temperatures to the surface. And it's highly critical that you know that. The old saying is ignorance is bliss. Happy-go-lucky, you don't see any defects, and it seems like everything is okay. But in reality, you're in a position where your camera is blind and you don't know it. See, if you could really know and understand how many things you're not seeing, you would become very, very concerned. See, so that's one of the big items that we try to cover in the class, because you've got different, what I call delta T windows, where you can open up information. And then we get into the outside, and you've got to deal with Mother Nature and the environment that she gives you. Because in the transition of the nighttime going into the day, or going from the daylight hours into the night, you have different delta T windows that can open up. And you get different types of materials, ephes and stucco, brick, siding, hardy board, and each one of those is uniquely different in how you can open up a delta T window. So this is a big point that we try to cover in the class. Also dealing with the subject of resolution. We get the question posed to us all the time, what type of camera do I need to buy? And my suggestion, and I've gone over this with other thermal imaging schools and instructors, I've compared this information with the ResNet standard, is that for a home inspection, it is recommended that you use a camera with at least 120 by 120 resolution. And I know that that kind of camera costs a little bit more money, okay? Now, I don't sell cameras, but I will insert right now and tell everybody that our students get the lowest priced cameras in North America. And you can write me an email later and ask me for a quote, and I'm not going to get into all that right now. But we've been buying cameras for so many years now that we get these incredibly deep discounts. And I don't sell cameras, but I do find these deals for our students. But if you'll stay with the resolution of 120 by 120, and then there's a certain rating of the noise factor, or what we call a fuzzy picture, and that's called the MK rating. And I'm not going to get into the technical details on that. And the other thing to consider about a camera is the optics. What is the lens made of? And it used to be the only kind of lens that they would utilize was a germanium mineral content. They cannot use glass with an infrared camera because infrared frequencies cannot pass through glass. Well, nowadays they figured out some other compounds, and they can mix these things with germanium, and they're creating smaller and very poor quality optics the lenses are becoming very cheap to manufacture. So as a result, there's a lot of cameras out there that have poor resolution. They have a lot of fuzziness, which is a low MK rating, and they have very cheap optics or a lens. So the end product is a resolution that is very poor, okay? And if you can imagine looking through a piece of paper with a bunch of holes in it, and the holes are, say, 3/4 of an inch apart, that's what it's like with your camera trying to see with a low number of resolution detectors. So your processor in your camera has to process these gaps and these spaces in the image, so you get blobs of information. It's not clear and concise details, but you get blobs of information, and the camera has processed it to fill in all the gaps. So this is the drawback of buying a low resolution camera, is that you don't get the details that are needed to diagnose things, okay? So let's go on to the next slide. And I know I'm just covering a lot of information quickly, but we've got to cover this in a limited amount of time. There you see on the screen is a breaker panel, an electrical system in the residential environment. I have discussed thermal imaging with electrical engineers, and there are a lot of different patterns and things in the electrical system that are revealed through the pattern. It's the shapes of those heat signatures. It's not always a very high temperature, you know, a very hot breaker or a very hot wire that reveals a defect. Many times it is a low temperature, but the pattern tells you that there is a defect and it's developing and getting worse and worse. So this is another reason that you need good resolution with a camera in order to see the details in the electrical system, to see the pattern and the images in a detailed revelation of the thermal image, and not just blobs of fuzzy heat signatures. You know, anybody can buy the cheapest camera in the world and you see this big blob of heat in the electrical panel, and you think your thermal imaging camera is revealing information, but in reality you can have such a lack of quality that you can't diagnose the low levels of heat and the precise details of those different patterns and signatures of what they're trying to reveal. So going around the house looking at switches and plug outlets and up in the attic and the junction boxes and pigtail wire connections, there's a lot of information with the electrical system, and you need those details when you're trying to diagnose those things. Let's move on to the next set of pictures there, Ben. So remember that when you're going through the electrical system, that we want to empower that electrical circuit with enough amperage to give a signature, a thermal signature, and reveal the identity of what the possible anomalies and defects may be.
Hey, John.
Now, in this image here, where you see the lack of insulation up in the ceiling area, and over there on the right side of the thermal image, you see some indications of a cooler spot where there's a roof leak and moisture is going down the inside of that wall chase. We cover in the class, yeah.
So,
yes, sir, Ben.
Sorry to interrupt you. I forgot there's like a 20-second delay. But before you go,
are you trying to talk to me, Ben?
Yep. So before we go any further, I'm going to post a poll.
I think I'm having a little trouble hearing you on my end.
Okay. if everybody could answer the poll. We want to do, John and I wanted to ask everyone if they use an infrared thermal camera or device in your services. So if you could just take a moment, we'll do a 30-second poll, and we'll get some answers. A lot of people are answering. We have almost 80% voting, over 80% voting, a little bit more. Let's try to get everybody to vote, and then we'll see what the polls are. Almost everyone's voting. A couple more seconds. So do you use infrared thermal imaging in your services? Select one of them. And all right, we'll close the poll. So no, we had over 90% answer, and no, but they are considering it. So John, you can, we'll talk about that later, of where John McKenna can send his students in the right place to find the right camera for the right amount of money. There's a question here about where do you find one that's affordable for the beginner. So John has already spoken about that, but if you take his class, he sets you up with not only the training, but also the right camera. So John, I apologize for interrupting. I know we practiced that I would do a poll in the middle of your presentation, but there's a bit of a delay in your audio because you're in the Dominican Republic. So whenever you're ready, you can begin again. So John, are you with us?
Right. Are you ready for me? Okay, you're ready for me to get started again?
Yep. Thanks, John.
Okay. You see there in the picture there where there's a lack of insulation in the ceiling. We spend a lot of time talking about not only the thermal imaging, but the wide variety of different income streams and the implications of what those different services entail. And energy evaluation is, yeah, can you hear me all right?
Yep, we're good.
I didn't know if you can still hear me.
Yep, we're good, John.
The energy evaluation is a major source of income, and okay, and a wide variety of other income streams can be created with thermal imaging, and we get into the application and step-by-step process of what other inspectors have done to create these other income streams. And a big service industry that is out there is the weatherization of homes and energy evaluations. Now, regarding the moisture, some insurance companies claim as much as 80% of the money they pay out goes back into moisture-related defects. So it is a huge amount of money that is attacking and causing expenses within a building when you're talking about moisture. And moisture is a very difficult thing to find days after the rain event has taken place. For example, if the chimney flashing leaks and that moisture is there and the walls are all wet, it's real easy to see in the first few days. But after that, it starts to dry out and evaporate. It starts to move down and migrate down the wall, and it becomes harder and harder to pick up that subsurface temperature, because every single day that moisture is evaporating and it's radiating less and less energy. So we talk about different techniques of how to find the moisture that's below the surface and bring those temperatures to the surface so that you don't miss these critical areas. You know, because moisture is conducive to mold, decay, and also wood destroying insects. And if it gets into the electrical system, it can cause corrosion and heat buildup. So you've got quite a few destructive side effects that happen in a moist environment. And the thermal imaging camera, when used with the right techniques, is a very excellent tool for finding moisture. And then that also opens up an entire new income stream with other contractors, insurance companies, you know, people that are needing moisture detection after they've been through a bad storm. So it's a real benefit to having the thermal imaging camera. Go to the next slide, Ben.
Yep.
And we'll look at the next set of pictures there. So when you guys get into thermal imaging, there is a wide variety of different applications, from the roof and the plumbing through insulation, the electrical system, the HVAC systems, moisture. You know, one inspector that's developed a way he can find the location of termite colonies within the walls, and he can open up a delta T window for about 20 seconds and take a thermal imaging picture, and then the image of the termite colony disappears. So he's developed a real sophisticated way to open up a delta T window, and we talk about those in the class. See, so with all these different examples of how to bring these subsurface temperatures to the surface, it's going to enhance the function of your camera by 1,000%. And that's the unique benefit of knowing how to manipulate your environment and also using Mother Nature to your advantage when using the infrared camera. We also get into how to set up your reports and liability issues, and how to communicate with the clientele, and some of the other issues that you're going to run into as far as legal issues and what you can and cannot say on certain subjects, and the implications of what you're creating when you are confronted with different people that own the house and contractors, because you're challenging people with the idea, who are you going to believe, my camera or your lying eyes? Because your camera reveals things that are not easily seen, many times impossible to be seen with the naked eye. But with the thermal imaging camera, you can reveal these things. So you've got to set your report up and confirm your evidence in such a way that it can withstand the argument and the debate process, because sometimes some real strong implications happen after your report is seen by contractors and sellers. The evidence of the defect except you and your camera. So there's a certain set of you know, information and report writing that's got to be in place to communicate that information in an effective way. Let's go to the next set of pictures there, Ben. Whenever you're doing thermal imaging, you want to keep the camera moving to different angles. Sometimes when you view things from the left and then view things to the right, certain images will stand out better and more information comes to the surface. It's the unique way that the frequencies come out of the molecules and the atoms within the materials, and moving to different angles sometimes will enhance the image of that information coming to the viewer screen of your camera. Now in this picture here, where you see the hot water, you can locate different elements, heating elements that are in a concrete slab, pipes that are in the walls, pipes that are in a concrete. And in this situation, there was a foundational movement and cracks taking place in the foundation. And it was getting over there in the same location where the pipes were located. So thermal imaging made it possible for us to communicate with the client that this foundational movement and the location of the pipes were in a place that it made the pipes vulnerable to possible damage if they didn't stop the movement of the foundation. And what I'm trying to do with these pictures is just give a little taste, a little variety of different things that the infrared camera can reveal. Let's go to the next set of pictures there, Ben.
That's it. That was the last picture.
What I always like to do is to have my clients with me while I'm okay. Okay. All right. Great. And if people would like to learn more about our outline and the content of the class, they can go to our website, and there's a sale that's going on right now. We have a little banner ad that says get an $80 discount on the class. So instead of paying $400, they can pay $320 and save $80. And once they sign up for the class, they can take it either through live webinar, or we have a recording of the class so they can do it at their own pace. So there's two different ways you can actually go through the entire class. You get $100 off of your InterNACHI membership fee, your yearly renewal fee, and you get 300 pages of class material with that as well. So I'm going to turn it back over to you, Ben, and unless you have some questions you want to talk about.
Yep, John, someone asked for your email address. So if you can give me your email address, I'll type it on the screen so everyone can have it. But for John's contact information and the information about his class, it's at www.infrared-certified.com. It's right on your screen there. And also, there's questions about, we all want to know what equipment you recommend. We are novices at this. Therefore, we don't want to make a bad investment. So John, if you want to comment about that as well. And I know there's a delay, so thanks for holding up with us.
Yeah, I'm having trouble hearing you, Ben.
Okay. Well, that was a great performance and presentation, John. So you may not be able to hear me, but I'll wrap it up. And I will send everybody your contact information through an email. It's a follow-up email so that everybody can get more information from you and from your website about how to become infrared certified. And I want to thank John McKenna for being here.
Yeah, I'm having trouble hearing you, Ben.
That's okay. That's okay. So I'm going to say goodbye to everybody, and I'll email everybody a link to the video recording and also for additional information. And again, if you want to get to John's website on your own, just go to www.infrared-certified.com. That's infrared-certified.com. Thanks, everybody. Thanks for showing up. See you next time.